This is example 6.3 on page 221 of our textbook. And this is an example utilizing Charles's law, which relates volume and temperature. Volume and temperature have a direct relationship, meaning that when one increases, so does the other, and vice versa. So we're going to solve this similarly to Boyle's law, in which we figure out what variables we're given and solve for the unknown. So the question states a sample of gas has a volume of 2.8 liters at an unknown temperature. When the sample is submerged in ice water at 0 degrees Celsius, its volume decreases to 2.57 liters. What is its initial temperature in both Kelvin and degrees Celsius? So on this slide, I have written the Charles law equation, as well as the equation to convert Celsius to Kelvin, because with Charles' law, in order for this relationship to be direct, our temperature scale has to be in Kelvin, the absolute temperature scale. So in this problem, we're given a degree Celsius measurement, and in order to plug this into our equation, it needs to be converted to degrees Kelvin. So first, let's figure out what our variables are. So first it says a sample has a volume of 2.8 liters. That is going to be our V1, 2.8 liters. It says it's at an unknown temperature, so that means we don't know our T1. And then it goes on to say that the volume decreases to 2.57 liters, so that is our V2. And our T2 is when it is submerged in ice water at 0 degrees Celsius. So before we plug anything into the equation, we need to convert our temperature to Kelvin. And to do that, for Celsius, you just add 273.15. So our T2 ends up being 273.15 Kelvin. Now we can rearrange our equation to solve for T1, and the easiest way to do this is by cross-multiplying the two sides of the equation, so that we have V2 times T1 is equal to V1 times T2. And then we can divide V2 on both sides to get that T1 is equal to V1 times T2 over V2. Now we can plug in our variables to solve for our initial temperature. So V1 is 2.8 liters, T2 is 273.15 Kelvin, and that is divided by our V2, which is 2.57 liters. So then my liters cancel, and I'm left in units of Kelvin. If you divide all of those, you should get that your T1 is 297.6 K. So we're almost done with this problem, but it asks for our temperature in both Kelvin and Celsius. So we have our first temperature in Kelvin. To get it back into Celsius, we're going to need to subtract 273.15 again. So if we do that, we get that our T1 in degrees Celsius is 24 degrees C. So our initial temperature in Kelvin is 297.6, and our initial temperature in Celsius is 24 degrees Celsius.